Hey there. So we're going to start off chapter 2 in our textbook today. And the chapter 2 is called Matter and Change. And it's a good introduction to just about everything that we're going to learn this year in chemistry. So we're going to do one section for about each video. And today we'll be focusing on 2.1, which is all about the different properties of matter. And there's many different ways that we can classify matter. We can talk about its properties. The first two are these terms that you may not have heard before: extensive and intensive properties. So if you look at the picture on the page, you'll see two different graphics of sulfur. And these two pictures of sulfur highlight some of the differences between intensive and extensive properties. If you look at both of the samples, you'll notice that both of them are yellow. Both of them would have the same melting point, but since the sample on the left is sulfur crystals and the sulfur on the right is powdered sulfur, then they would have different masses and they would have different volumes. And so if two samples have of the same substance would have that property, would have that same property, we would call that an intensive property because it's intensive. It is inside. It is part of what makes sulfur sulfur is that it is yellow. But an extensive property, think of that word extent. To what extent will you go? It means how much, how far. So one sample of sulfur may have more mass than another sample of sulfur. So let's write those properties in our notes. So an extensive property, definition of an extensive property, a property that depends on the amount of the substance present. So a property that depends on the amount of substance present. And you can even skip a line. And then what is an intensive property? A property, it's the exact opposite, right? A property that does not depend on the amount of the substance present. And I'm gonna, change my color of my pen just to get a little bit more emphasis there. So that does not depend on the amount of substance present. And I have two examples here. The first example of an extensive property is mass, because if I have a lot of sulfur, it has a high mass, and if I have a little sulfur, it has less mass, right? So what is the definition of mass? You probably learned this maybe in middle school, but let's write it down again. Mass is the amount of matter that a substance contains. So it's the way that we describe how much of something you have. The amount of matter a substance contains. Right? So obviously if you have a greater sample of sulfur, it has more mass. Now an example of an intensive property is density. We'll do a lot of work with density this year. You may remember that density, there's a formula for it, and is the ratio of mass to volume. And it's really interesting because mass is an extensive property. Volume is an extensive property, but when I take those ratios, when I take mass and divide it by volume, that number is always going to stay the same. The density of sulfur is a constant. Another way to think of an intensive property is if you could look it up in a textbook and say, what is the color of sulfur? The answer will always be yellow. What is the mass of sulfur? Well, it would depend on how much you have. Okay? A couple more vocabulary words here. We've been talking about this word substance. What do I mean for a substance? And a substance, what I really mean is maybe a pure substance. You'll see those two words sort of used interchangeably, right? But what is a pure substance? A pure substance is matter that has distinct properties and composition. Matter that has distinct, right? That means very specific properties and composition. We'll talk about what makes up a substance a little later on, but things like elements are substances, molecules are substances, ionic compounds are substances. What is not a substance? If you're not a substance, you're a mixture, and that's what we'll be talking about in the next video. So we said that substances have distinct properties. We're going to talk about two different types of properties. Right now we're going to talk mainly about physical properties. So what is a physical property? Well, first of all, its opposite is going to be a chemical property. We'll go over that definition in another video. But a physical property is a property that can be measured or observed without changing the composition of that substance. So a property that can be measured or observed without changing the composition of the substance. What are some examples of that? Well, think about what we were looking at sulfur, right? If I take sulfur and I look at it and I say it's yellow, it's still sulfur. And these are going to be things like color, even like melting point. And one big example of a physical property is the state of matter that the substance is going to be at. And that's what the next page in your notes packet is all about, looking at the different states of matter. And again, I think this is concepts that you have done in middle school. We're just reminding you of them and reinforcing them. So matter has anything. Maybe you guys remember the definition of matter. Again, matter is anything that has mass and takes up space. Matter is just about anything. Matter is not something like speed. That's a noun, but does it have mass and take up space? Or imagination. Does that have mass and take up space? No. But just about anything that you can look around and see, and even lots of things that you can't see, like air, it has mass and it takes up space. The three fundamental, we know this, states of matter are solid, liquid, and gas. Now, there are other states of matter. You may have heard of plasma. There are some really crazy things that happen to matter when you get really low temperatures, like very close to absolute zero. That's for a different course. What we're talking about here is matter when it is composed of atoms, consists of, or is solid or liquid or gas. So changes in state are a result of energy being, and this is added or removed, right? You know that if I have an ice cube, how do I get it to be liquid water? I add energy, I add heat. And just the opposite, if I have liquid water, how do I get it to be ice? I remove energy or heat. So here are cute little pictures of our three states of matter. And these, like doodle notes, and I have a couple of these in every chapter. These are just something to make maybe the notes a little bit more interesting. And feel free to use your creativity to make them into, something that you want to look at, right? Like this little guy, he's liquid, so maybe we can color him in blue. Do whatever you want with it. They're your notes, and the more that you take ownership over them, the better you're going to remember them. Okay, so our first guy here is solid. So what do we know about solids? Solids have a definite volume and shape. When I mean definite, I mean not changing. It doesn't matter how much pressure you put on it. The shape of a solid is going to stay the same, and the volume of a solid is going to stay the same. If I just move, and I'm going to move to liquid and answer kind of those same questions for a liquid. Well, liquid would have a definite volume, but not a definite shape. Think of taking water from one container to another. Its volume is going to stay the same, but the shape is going to be whatever the shape of the container is. And of course, a gas has no definite volume or no definite shape. Now, let's talk about how the particles are put together. So the doodle notes that I have say molecules. I want to maybe expand that and to just use the word particles. Because molecules, that's a very specific term. It means when you have two nonmetals, two or more nonmetal atoms held together by a covalent bond. I like the word particles because that could also mean a single element by itself, like iron, or an ionic compound like salt. So particles are tightly packed, right? They're really close together, and they have a regular pattern, and they vibrate in place. Right? The particles of a solid have the least amount of energy of the three states of matter, and they're moving around the least amount. And they're not really, translocating from one point in space to another, but of course they have to be moving, because when a particle is not moving at all, and when its protons and neutrons and electrons are not moving at all, that's absolute zero. So they're moving, but what they're doing is they may be vibrating, they may be spinning around, but they are not moving from one location to another. So what about that same concept, but in the idea of a liquid? In a liquid, the particles, right? Whatever it's made of, the particles are loosely packed and flow against each other, right? They can move past each other, but they're still really close together. Think of the difference in volume from when you put liquid water into the freezer and then take it out as an ice cube. The volume changes a little bit, but not significantly. When you will see a really significant difference is when we talk about gas, right? And of course, in gas, the particles are very far apart and can move freely. Okay, now let's talk about this last diagram here. In this diagram, there's space for you to draw pictures of what a solid and a liquid and a gas look like. So we know that when we have a solid, the particles are very closely packed, and they're also in a rigid geometric 3D pattern. So notice that the particles, the little circles that I drew, are super close together, and they're in a very close pattern. Whereas in a liquid, you're still going to see the particles relatively close together, but you shouldn't really be able to find much of a pattern to how they are. Whereas in a gas, in this, I'm only going to draw like maybe 3 circles, and sometimes I like to draw them with little lines like this, sort of just showing that they are moving quite fast. Okay, and now let's talk about what goes in these arrows. What is going to go in these arrows are the names of the phase changes. So you probably know almost all of these. When I go from a solid to a liquid, what do I call that? That's melting. And then what happens when I go from a liquid to a gas? That's evaporation. And then let's go backwards. When I go from a gas to a liquid, that's called condensation. Right? Maybe if you have an iced beverage in the summer and the sides get wet and you can say, oh, there's condensation on the sides. That's because the water that's in the air has turned to a liquid on the cold beverage, right? And then going from a liquid to a solid, it's nothing fancy. It's called freezing. Now, the arrows up the top and bottom, those may be words that you may or may not have heard of before. These are when you make a phase change without going through liquid first. So if I take let's start with a solid, because this is one that you may have heard of. If I start with a solid and I go directly to a gas, but without having to go through the liquid phase, and you don't see this often, that is called sublimation. Is when and that is a solid, goes directly to a gas. And if you have ever used or heard of dry ice, this is a dry ice is solid carbon dioxide, and that sublimates, that goes right from a solid to a gas without going into the liquid phase first. What is the opposite of that? Well, that would be when a gas goes directly to a solid without becoming a liquid first. That's called deposition. Right? It's when a gas goes directly to a solid. Okay? And again, just as a review, what makes these changes occur? We know that increasing the kinetic energy of the molecules or particles, right, of the substance. Right? Look at that arrow there. You know that on the right-hand side you have a gas. So this is, I'm just putting that as red to kind of symbolize hot, whereas in the gas it's cold, in the solid it's colder. It's a little bit, I just symbolize that with blue. So mark up these notes, feel free to color in these just to make them a little bit more visually interesting if you want. And the next video will be on mixtures.